Welcome back to our sixth lesson in our course, Advanced Kubernetes, Terraform, and Flux. In today's lesson, we're going to talk about security, where specifically we're going to talk about the users, the developers in our organization. They want to access cloud resources. How do we manage those users properly? So we need to take our team, and separate the users to groups, and then work with service account and impersonation, and work properly with permission and roles while focusing on security best practices. This is what we'll focus on this lesson because I see it often neglected in many organizations. Many organizations are giving a very permissive roles to their developers because they simply do not want to deal with this topic properly. So in today's lesson, we're going to talk about security and focus on security best practices. So how did we create cloud resources until now? So to create cloud resources, you first have to authenticate. And then whomever you're authenticating as, whether it's yourself or you may be impersonating a service account. So until now, we authenticated as ourselves. Then we need to give the person we're authenticating, in this case ourselves, we need to give ourselves enough permission to create those cloud resources. And then we configured Google Provider in our Terraform project to create those cloud resources. So basically what we did is we authenticated as ourselves, we gave ourselves a lot of power to create cloud resources, and then we managed to create those cloud resources using our own user with a lot of permission to our own user. And basically what we did is I authenticated as my user and gave my user a lot of permission. For example, I see a lot of organizations that simply how they deal with it is they give a user organization owner permission, which is godlike permission to do pretty much whatever they want. So this is a lot of times how organizations are dealing with, okay, let's give our users a lot of power so they can create cloud resources. And what is a good programming course without a reference to Star Wars? Basically what we're doing here is giving our team, our developers, unlimited power. And this is highly unrecommended. So just if we give it as a Star Wars reference, it will probably sink in. So this is really important not to do it. Not to give any users, any developers permissions more than they should. And I'll give you a very big tip. Users, developers, even DevOps, even admins should not have permission to create cloud resources. We'll talk about it later because it sounds weird. So who's creating cloud resources? Service accounts. Users do not have permission to create any cloud resources. We'll see an example of this later on. But that Star Wars reference should be tattooed in your head to not give so much permissions to your developers. So let's talk about what the problems with giving too much permission to our developers. So it's not recommended to give cloud creating permissions to our developers. In fact, don't give your developers any permission to create cloud resources. And the biggest benefit of doing so, that those users, if they don't have permission to create any cloud resources, they will go to the web UI and they cannot do any changes to infrastructure using the web UI. They simply do not have the permission. This enforces them to use the infrastructure as code project to make cloud infrastructure changes. So this is something that for me is the biggest benefit, because always my goal was good to manage all the infrastructure as code and all the infrastructure in code with the coding technology, and always team members went to the cloud and created resources which were then untracked, and the prices that we paid for the cloud was skyrocketed. A lot of resources were open and not closed and not tracked, and nobody knew what resources, what they're there for, who opened them. So everything needs to be with infrastructure as code, documented, version control with the proper history and documentation. And to do so, we have to be declarative with our infrastructure. But if we don't prevent our developers, if we don't take the power away from them, they will use the web UI, and I see it all the time. Just people go to the web UI and they open a new database, they open a new compute engine, and just take that power away from them, and you'll see that everything will be managed by infrastructure as code. So this is the biggest benefit. It fits my OCD that I was constantly anxious that someone's going to the web UI and creating resources. This forces all the developers This shuts down the web UI, and the web UI is for viewing purpose only, for log viewing, for stuff like that, not for creating new resources. Just take that power away from them, and you'll see that everything will be much more organized. It's hard to manage proper user permission. If you give a user a lot of permission, in fact, if you deal with permission on an individual basis, meaning you take your developer and you take every developer and you say he needs this permission and that permission, it's much more easier to take the developers and place them in groups. It also helps you in a management perspective. If you take organization, it's sometimes easier to see the groups, the teams, rather than the individual, and it's easier to manage user permission. It's much more, if you give individual permission, it's almost impossible to maintain the principle of least privilege. That principle says, as we mentioned, give the minimum permission that a principal needs in order to do its job. So it's almost will be impossible to maintain if you don't place your developers in group. If you give too much permission to a developer, it will be impossible to implement pulp. If accounts are compromised, then there is a lot more damage that can be done. So if account is compromised and you have a lot of permission, and that account has a lot of permission, a hacker can go to the web UI, can create resources, can basically do whatever he wants. If you take away the permission to power, so the damage that is done is smaller. Also, I saw a lot of places that are working with freelance developers. Sometimes they take a developer for 1 month, for 2 months, they barely know them, and suddenly because they don't manage the permission properly, they take a freelancer for 2 months and they see the permission on that freelancer is organization owner. So that's a crazy permission to give to someone you barely know. Also, developers sometimes leave the workplace. So it's better to keep things at a minimum, keep users in groups, keep the permission in groups. It's easier to revoke user permission and to manage user permission in that way. Often powerful roles are given due to hard management of permission. If you don't manage the permission properly, you'll often see that your things get complex and you just simply go to the easier solution of giving a lot of permission like organization owner instead of dealing with it properly. So often those powerful roles are an indication of bad permission management. So here's the identity access management strategy that we're going to take in our infrastructure as code project. Our project that includes cloud resources and managed Kubernetes and Flux. Everything is open source and MIT licensed. You already got almost 20 stars. So if you like the content, if you like the example, make sure to star our repository. So everything, our IAM strategy approach, everything will write down in this project inside our infrastructure as code project. We'll implement everything here, and you see how easy it is to maintain and how organized and how secure everything will be after we finish with coding this lesson. So here's the identity access management strategy. First of all, we're not going to think about users as an individual. Rather, our teams will be organized in groups. All our developers are going to be organized in groups. So we're going to give permissions to the groups and simply place the team developers inside the groups so they will inherit all the permission of those groups. Now, a team member not necessarily have to be in a single group, right? So a team member can be a developer, but it can also be, I don't know, in a database admin group. So a user in our team can be in multiple groups. Now, the permission we'll give the groups are not permission to create cloud resources. In our sake, all the permissions for the groups that the users will get, maybe they can look at the web UI in terms of looking to see logs and stuff like that, to see data, but they won't be able to create any cloud resources using their permission. So the principle that will have the power to create cloud resources are service accounts. And there will be different service accounts for creating different aspects in our infrastructure as code project. So there might be a service account that is called a daemon that will take care of all the other service account and permissions and roles. There might be a service account that will take care of DevOps things and will be in take care of the common infrastructure and DevOps permissions. There might be a service account to deal with developers, what developers can create. And those service accounts, they will have the permissions to create cloud resources that represent here. The blue is the cloud, and red is a service account can create some cloud resources. Now, in order for a team member to create a cloud resource, what the team member will have to do is it will have to impersonate a service account. So impersonation is creating a token to identify as a service account. And similar things exist also in AWS and Azure. I think Azure it's act on behalf of, and I think in AWS it's assume role, but the principles are very similar. So in GCP, it's called impersonation. So I am impersonating a service account, and then I have access, using that service account, I can create cloud resources. So this is going to be our strategy, and we're going to implement this strategy in our infrastructure as code project to make everything simple and make all this plan in our Terragrunt and Terraform-Tofu project. So here are a few recommendations if we want to work correctly with permissions. So first of all, we will not work with basic roles. So Google has legacy roles that are called basic roles. Those are roles like roles admin, roles writer, roles owner, roles readers, role reader. Those roles are highly permissive legacy roles, and Google in their docs also mentioned not to use those roles. We will not use them at all. Instead, we will use predefined roles or create custom roles of our own. Predefined roles are also roles that are supplied and maintained by Google to give certain permission to a service in GCP. So we will mainly use those predefined roles to give access to certain services in GCP. We will use the least privilege principle. This will be a principle that guides us, that what the principle is saying, that we need to give permission, the minimum amount of permission, in order for a principle to do the work that it's supposed to do. So we're going to focus on this principle when we give permission, and we will give the minimum amount of permission for each of our users and service accounts and groups. We will work with groups, meaning we will not work with a permission on an individual level. Rather, we will take a team member and we will place that team member in a group and give permissions to the groups. That will help us organize the permission, organize our team. We are going to work with short-lived generated tokens. So when you impersonate a service account, when we will want to create our resource in the GCP cloud, we will impersonate a service account, and the service account will create that resource. In order to impersonate the service account, we will generate a token. Now we'll generate that token properly and use short-lived generated tokens, tokens that expire very quickly, in order to not generate tokens that last forever and needs to be rotated. So we'll always aim to work with short-lived generated tokens. So those are a set of rules and best practices that will guide us through how to work properly with permissions. So here's the plan for this lesson. This lesson is focused on permissions and how to manage them properly in a Terraform-Tofu project. We'll talk about GCP principles like a user, a group, a service account. We will learn how to place those principles inside groups, and by doing so inherit the permission of a group. We will talk about permissions and roles and talk about predefined roles. We will talk about impersonation and how do we create a short-lived token to impersonate a service account and create a resource on behalf of a service account. And we will learn how to code all those concepts inside our Terraform-Tofu project. So we already have a repository. It's already now 20 stars, and we have a repository, and we have an infrastructure as code folder, and we have a Terragrunt project in this folder. And we will learn how to code all those permission concepts inside your Terraform Terragrunt OpenTofu project. Let's define what is a principal, right? This is the basic unit we're working on, that we're giving this unit permission. So principal is someone that we can give permission and roles to. And you have different type of principals in GCP. And we're not going to work with all of them. We're mainly going to focus on 3 of them: service accounts, groups, and our Google accounts, or we will call them user. So, but you have different, even a pod in Kubernetes is a principal in GCP. So a principal is, we give permissions to principal. And the principal we're working with, we're going in this course, will be a user. So our developers, our teams, we are going to work with groups, right? We're going to place permission in groups, and groups allow us to group together principals, right? A group does not have to contain only users. A group can contain service accounts, or it contain other group, but it allows us to group together principals. In fact, a group can contain principals that are defined in GCP. But we group together principals inside a group, and then those principals are getting the permissions, the roles that are assigned to the group. And we're going to talk about service accounts. So service accounts are usually are like users, but they're not really connected to a user. Usually we place service account to be our computational engines or servers or apps are represented by service account. So it's someone that can have service permission, but is not really logging in. It's not really a human. So we are going to work with these principles. So let's talk about a few of the principles that we just mentioned. We mentioned a principle that is called group. A group allow us to take other principles like users and place them in a group, and then those users inherit the group permission. So we'll usually manage the permissions in our organization using groups. Now, a principal in a group, as we mentioned, will inherit the permission given to the group, and a principal can be placed in multiple groups. So if I'm in multiple groups, I get the permissions of all the groups that I'm in. So if we examine GCP groups, there is a weird thing in GCP groups that if you want to group permissions, those permissions are managed by Google Workspace and not GCP IAM. So we'll have to take this under consideration, because we will create an admin group, and that admin group can impersonate a service account that will be able to create groups and manage groups permissions and manage principals and groups. And to do that, we will have to take that service account and give it permission from the Google Workspace. We'll touch a bit about that later on when we deal with the problem. But we have to remember that in order to create groups, there is some permission that we need to set in the Google Workspace. So the next principle that I want to talk about is service account. Now, a service account is a special kind of account. This is from the Google Docs. Special kind of accounts typically used by application. In our case, application, we will use it for Terraform, our Terraform application, or compute workload, such as a compute engine instance rather than a person. It does not represent a person. A service account is identified by its email address, which is unique to the account. So a service account does not represent a person. It represents application or compute workload. And this is a strong point here. A service account, I can create a service account. I can give a special permission to this service account, a special impersonation role to this service account that will allow certain principals, like certain users, to impersonate this service account, to act on behalf of this service account. This is a perfect tool that will allow us to eliminate the permissions that we give to users to create cloud resources. So we will eliminate all cloud resources creation privileges to users, and they will have to impersonate a service account in order to create cloud resources. Which means a user in our organization cannot go to the GCP web console and start creating databases or compute engines or open resources. They are limited. The web UI will only be used to view logs. This means they will have to create cloud resources using our infrastructure as code project. This is a perfect way to control all the cloud resources that is created in your organization. Quite simply remove all permission from users to create cloud resources. You're incomplete. The infrastructure as code project is the source of truth of the cloud resources that you create. This means that everything is version control documented. You see everything that is open. You can track everything that is open. You don't have things that developers open that are untracked and cost a lot of money. So this is a perfect tool to eliminate all users from just creating stuff in the web UI, and they have to create cloud resources using our infrastructure as code project. So this is our first best practice tip regarding our developers' permissions. So users, developers in our organization cannot have any permission for creating cloud resources. Their user cannot have those permissions. They have to impersonate a service account, and only service accounts have permission for creating cloud resources. So this will eliminate our developers from going to the web and opening cloud resources without using the infrastructure as code project. You eliminate the problem from the root, and believe me, if you don't do that, developers will create resources using the web UI. No matter how hard you try to tell them, how many times, how many Slack messages, how many mails you write, they're always going to go to the web UI and create resources that way. You have to eliminate their permission to do so. This is the only way you can create the resources using infrastructure as code project. So eliminate their permission for creating cloud resources. Now let's talk about GCP services. So GCP, Google offer cloud services, and those services are infrastructure as a service, platform as a service, software as a service that are offered by GCP, and you pay for them. And a service has a title and a name. So each cloud service that GCP provides you with has a title and a name, and you can see the services by doing the gcloud services list command. So you have to install gcloud, and then you can do gcloud services list command. And when you run this command, you'll see a list of enabled services, and you see their name and you see their title. So for example, for managed Kubernetes service, the name of that service is container.googleapi.com. Now remember, the name of the service starts with a prefix of the service name, in our example container, and then usually a suffix of googleapi.com. Now we will need this first name, the container, when we're searching for roles, and we'll explain later how to use that to find the appropriate role. If you manage to know how exactly to find the role for your services, you will be able to find the minimum role that you need in order to keep the pulp, what we mentioned is principle of least privilege. So remember this, it will help us search for the minimum role that we need in order to maintain pulp. So these are services and the name and title of the services, and we'll remember the short prefix of the name of the service when we search for roles. In order for a principal to use a GCP service, that principal needs to have the proper permissions for that service. So permission will allow principal to perform an action on a GCP service. And based on the service title, as you recall, we created a list of those gcloud services, and each gcloud service has a name, and that name has a prefix. Using this prefix, we can look for the proper permissions to assign to a principal in order to use this GCP service. And we can do this in the GCP docs. They have a permission reference. So let's look at the permission reference of GCP docs. I'll place the link in the description as well. You'll see here a search for permission. So if I want to search for permission relating to Kubernetes, I'll search for the prefix container. Now I have different kind of permission on Kubernetes, for example, container API service create. And on the right side, usually I don't assign only one permission to a principal. I want to assign a role, which is a group of permission. And on the right side, it shows you the roles that contains this permission. So the first roles are role owner, role editor. Those are called the basic roles. It's not recommended to use these roles. They are legacy roles, they're highly permissive, we will not use them in this course, and in fact we do not recommend using it at all. So if we want a role that relates to Kubernetes, we'll look for a role that contains the prefix container. For example, Kubernetes engine admin, but admin is kind of powerful role, so we can search for something a bit more lightweight, and we can look for example, Kubernetes engine developer. So if you need a certain permission, usually you'll search the permission in here and you'll find the proper predefined role that you need, and then you'll assign the principal this predefined role. This is the trick of how we manage to easily find the right permissions and the right roles to assign to each principal the minimum amount of permission that it actually needs. So permissions are grouped in roles. So we usually don't work with individual permission, we usually work with roles. And in this course, we're going to work with something called predefined roles. Those are roles that are managed by Google. They're dedicated for some kind of logic or service. And the way we find predefined roles is by using the GCP documentation. They have a predefined roles reference page. So if we go to this page, I'll place the link in the description, we'll have a similar search like we had in the permission. And again, we're using the prefix of the service that we want to give permission to. For example, Kubernetes, the prefix is container. So we can search for roles, container. And using this, we can find all the roles that relate to Kubernetes in GCP. So container admin, container cloud KMS, container cluster admin, and so on. So we can search the permission page if we're missing some kind of permission. Then we have a list of roles. We can also search from the roles to see the list of permissions on the right. So this is how we search for the proper role and give the minimum role that is needed to do the job. There are also something called basic roles, like we talked about. Those are rules like owner or editor or viewer. We are not going to use those roles. They're highly permissive and not recommended. So consider them as legacy role. And there also is something called custom roles. And custom roles, I have a link of the documentation here. Custom roles allows you to create your own roles, group together permission. You can also base your custom roles on a predefined role. So you can take a predefined role, for example, and using custom role, you can remove certain permission from that predefined role. You can also take multiple predefined roles to custom roles. So you can play with it, but we're not going to touch it in this course. Mainly for most simple use cases, the predefined roles, I think, are enough, even if they're not perfect and maybe have 1 or 2 permissions extra. It's still, I think, good enough, and this is what we're going to use in this course. So here's another tip from this lesson. This time is a bad practice tip, so it should be avoided, so do not do this. So it's regarding basic roles. Basic roles should not be used. So let's see in the GCP documentation regarding basic roles. In GCP documentation, they mark in red, caution, basic roles include thousands of permissions across all Google Cloud services. In production environments, do not grant basic roles unless there is no alternative. Instead, grant the most limited predefined roles. This is what we're going to do. We're going to give the limited predefined roles or custom roles that meets your needs. When we're talking about basic roles, we're talking about roles admin, roles writer, roles reader, roles owner, roles editor, roles viewer. The amount of time I went to organization and saw different companies and saw roles owner on their organization distributed between different developers, it's amazing how much I saw this bad practice happen. And this is so much power to give to an individual person that it should be avoided at all costs. So a tip from us, do not use basic roles at all. We are going to protect ourselves even further by using something called impersonation. Impersonation allows a user or a service account to impersonate another service account. This means impersonate means act on behalf of another service account. So I can say I'm a user, but I don't have privileges to create GCP resources. This means I have to impersonate a service account, given that I have the right permission to impersonate that service account. So I'm impersonating a service account, and that service account can create GCP resources. This impersonation is going to be done by generating a short-lived token. This means that we don't have to rotate tokens. We are creating a short-lived token which is expired very, very quickly, and it's much more secure than creating a long token that we have to rotate. Creating GCP resources will be done by service accounts. This means that we need to impersonate the service account in order to create GCP resources. And what we are doing is accept the service accounts that can create GCP resources. We're eliminating all other principals, including all our teams, developers, users in our organization. We're eliminating their ability to create GCP resources without impersonation. So they cannot create GCP resources means they cannot go to the web and to the GCP console and create GCP resources. This means we're forcing them to create GCP resources with our infrastructure as code project. So why is impersonation so important in terms of working with Terraform, OpenTofu, that they need to impersonate in order to create those GCP resources. Why not run Terraform in OpenTofu with our user like we did before? Instead, we'll stop and doing impersonation. So why use impersonation in our Terraform OpenTofu project? So it's our recommendation that users, human beings in our developers in our company should not create GCP resources. Rather, they impersonate a service account, and a service account will create, or different service accounts will create those GCP resources. And here's a few reasons why it is so important. First of all, as we mentioned before, and one of our best practice tip, it eliminates the ability of all the users in our organization to go to the GCP web console and create cloud resources using the web. And this pushes them to create those resources using infrastructure as code. This means that all our cloud resources will be manageable in Git and trackable with good documentation. So we'll have a good history of our cloud resources, and there are no users going to the web UI, opening cloud resources that we cannot track and we cannot later delete or save expenses. So the first advantage of using impersonation is our ability to control cloud resources and eliminate the ability of other users to do things not in our infrastructure as code project. There is advantage of enhanced security. So a user needs to create credentials, and we're using short-lived credentials to impersonate a service account. That means another layer of authentication that one needs to pass in order to create cloud resources. Our tokens are short-lived, so there is also security in that. So all this will enhance your security, and your cloud resources creation will be much safer, much harder to damage your organization. By creating cloud resources, it will enhance that security. It's better permission management. So it's going to be really hard and cumbersome if a user in your organization, you start giving a lot of permission to create cloud resources. It's going to be very hard to track. It's going to be very messy. There are a lot of users with tons of permissions and dealt hand to hand. It's much easier if you place the users in groups and you focus on what the user, not on what the user creating in the cloud, rather what that user in your organization is using. If he's a developer, maybe I can place a developer group. Does the developer group needs to access the production database? In many organizations, the answer will be no. Developers might only need to access staging or non-production environments. So you organize your permission in group and you organize it properly, and you do not have to overextend tons of permission for users. You simply give the users permission according to what they're using in their day-to-day job, instead of what they're using once in a while to create resources. You don't focus on that, you focus on the actual permission that they use day-to-day. It's better CI integration. So a lot of the time we want to combine our Terragrunt creating resources with a CI that will run things for us. That CI will probably be identified as some sort of service account, and it's going to be easy to manage if you just simply place that service account in the correct group in order to give it the right permission and the minimum permission. It's also something that I saw a lot, that CI, often that service account of the CI get far too much permission and not using the principle of least privilege. So now everything is organized. You can give the CI, split the CI to different service account, have them impersonate to whomever resource they need to create, keep things as minimal and organized as possible. So it's much easier to integrate your CI when it's a service account that needs to impersonate other service account. Better audit logs. Now in GCP you can access a principal and you have the logs of that principal, so you can see what that principal is doing in the cloud. So it's much, you have much better, if you have, for example, mess in your Kubernetes resources, you know you have service account that creates Kubernetes resources. You simply go to that service account, go to logs, and you can easily see what that service account is doing, easily debug, is able to track issues of that service account, better damage control. So If one of our users get compromised, so it's easier just exit the group or revoke the permission to impersonate a service account, or if a service account you see in the audit logs of that service account that it's doing something weird, you can always delete that service account and create a new one. So it's much easier if something is compromised to know exactly your bottleneck and what should be cut out in order to be safe again. So there are a lot of advantages in impersonation. I think the first one, our ability to eliminate users for creating cloud resources using the web UI, for me it was the most important one. It's helped me a lot to manage my infrastructure as code project without worrying that someone might go to the web and create resources that I do not track. So everything is much organized, and for me that was the killer feature in doing this, everything we're doing today using impersonation and not using the user account, rather forcing user to impersonate to create cloud resources. So eliminating the user's ability to use the web UI for creating resources, only that was completely worth it for me. So time to implement our impersonation in our Terragrunt project. And we want to do it as simple as possible. We don't want developers to adding stuff to our infrastructure as code project and start thinking about which service account do I need to impersonate to. We want everything to be declarative and very simple for developers. And this is how we're going to implement impersonation in Terragrunt. So the impersonation will be done in our root Terragrunt. So as a reminder, this is our project. Actually, this is our GitHub project. We're already at 21 stars. And we're really trying to build a proper starter kit for all the DevOps, Kubernetes stuff. And I haven't seen something that is well-maintained, documented, and so feel free to support our effort and start this, this repository. The link for the code is in the description. So what we're going to do is we're going to our infrastructure as code project to our root Terragrunt, which is here. And in here, we are going, we basically have this logic here, right, to generate a provider. This generate provider is placing a Google provider, and we're just simply, currently we're identifying as our user. What we're going to do is we're going to change the logic here. Instead of identifying as our user, we'll impersonate as a service account. So the main impersonation logic will be placed in this file. What we're going to do, each folder in our project can place a file called, we will call this file IAM, Identity Access Management.yaml, that contains the service account that we need to impersonate to in order to create resources in that folder. And if that file, and basically what we'll do in Terragrunt, whenever you're in a folder trying to access file, you're going to automatically impersonate to the service account in the IAM.yaml file. If there is, you're in a folder which does not have infrastructure IAM file, then it will go to the parent and look in the parent or in the grandparent. So it will go to the folder up the hierarchy until it finds IAM.yaml. Now, if it goes all the way to the root and it doesn't find this file, then there is no impersonation, and you will simply try to create resources using your own user. So basically, this is how our project will look like. If this is our infrastructure as code folder, and in it we have, for example, prod, non-prod, common, various folders that describe the different parts in an infrastructure, Inside those folder or children folder, there'll be a special file called IAM.yaml that contains the service account that we need to impersonate in order to create resources in the prod. And the impersonation will be automatically inside the root Terragrunt by configuring this provider here. Okay, so this is the general plan, and now it's coding time. So it's time to modify the root Terragrunt, modify this section to actually look in one of the hierarchy of the folders for the IAM file and then impersonate the service account from that file. So let's code this together. So let's start coding our impersonation logic. So what the impersonation logic will do, it will search for a file that is called in the folder where we're activating Terragrunt. It will, for example, let's say we're activating in common, or we're activating in folder, or whatever Terragrunt file we are executing, it will search in the folder hierarchy. For example, if we're running the Terragrunt in root, it will search in root, then in folders, then in common, then in the root. And it will search for a file called iam.yaml. We'll search for the file, and we will place in this file the service account email that we need to impersonate to in order to create resources in this folder. And the structure of the file will be email and then the email of the service account. Now, this is not something that is built in or something we need to implement this, right? So we need to do a logic in the Terragrunt, in the root Terragrunt file. We need to implement a logic that will read the file iam.yaml. Now, we have that logic already, right? So we can do similar to what we did in the common vars, and we call it IAM, and then search for the file iam.yaml. Now, of course, there might be a case where this will fail, and we want a fallback. What if we don't have, at the beginning, we don't have any, right now we don't have any service accounts that creating GCP resources. So at the beginning, we won't work with this IAM file because we don't have those service accounts. So what we'll do is we'll do a fallback that if this file is not found in any of the parents, we won't do impersonation. Rather, we will create the resources like before using our user. So what we'll do is we'll cover this with try. Now, the way try works, okay, try is a function in OpenTofu or in Terragrunt. The way try works, it tries to evaluate each expression until it finds a successful one. So if this one fails, we can supply a fallback of an object with the email of an empty string. So this will never fail. And in case we have don't have iam.yaml, it will provide an object with an empty email. Now we can do something like this. We can use this. This is a string, right? And this string is supported in OpenTofu, in Terraform, right? So it's string in the, it's in the documentation string and template. It's we have here a Unix shell language allow multi-line strings to be expressed more clearly. So that's a here doc string style, and we can supply strings here. Now we can do certain manipulation in the string, right? So we can add, for example, an if, we can add a for. So for example, we can add an if using % and curly bracket. So I can do something like this. So I can place an if I have a length of iam.email which is greater than 0, meaning if I have an email which is not an empty string, then create some kind of logic. So in here we'll provide the logic to using impersonate the service account. Or we can provide an else that will authenticate as a user for fallback. And this is the logic that we placed before. This logic here, it simply belongs to the case that we had before, right? So we're authenticating as our user. This case where we don't have an able to impersonate. This part we have to implement, this logic where we're impersonating a service account. So let's do this logic where we have an email and we want to impersonate that service account. So let's create the impersonation part. So we are in this if, and there is an IAM email where we need to impersonate to. So in order to impersonate, we will use a Terraform data block that is called Google Service Account Access Token. And this is the docs of this data block. And using this data block, we can retrieve a token to impersonate to another service account. So let's go over what this data block is doing. So this data source provides a Google OAuth 2 access token for a different service account than the one initially running the script. So the one that's initially running the script will be the user. Each user that is running the Terraform apply or the Terragrunt apply or Tofu apply is the initially running the script. So that will be the user. We'll create an access token for a different service account. Which service account? The one that is written in IAM email. Great. To allow service A to impersonate service B, grant the service account token creator. We'll talk about this later on. In order for me to impersonate a service account, I have to have certain permissions on that service account. So this is the regarding the permission that you need. It's called service account token creator. And let's see in their example, they're using this data block. But before we can use this data block, we actually need to define the Google provider, right? Because this is a part of the data block that Google provider is in charge of. So first of all, we will define a provider Google. We will go here and we will provide a provider Google. And I'm going to actually alias it and call it impersonation. So this is not going to be, this is a Google provider that I will authenticate using my own user. So, and it's not going to be the default. This is why I'm aliasing it, because I'm only going to use it to create that token. Now, once this is created, I can go to the data block and I can create an access token for another service account. So let's take this from the configuration. So which is the provider is not Google, it's Google.impersonation, because I have an alias here. The target service account that I'm trying to impersonate to is not this, is not a constant, but it's a local IAM email, right? It's this. Great. The scope, I think it's also the default, but this is the scope we need to access that to create a token, and the lifetime of the token. So this is a bit low. If the script is running more than usual, maybe we can set it to like an hour, 36,000. And this is creating a token. And now using that token, I can define a provider Google, which is the default, which is, let's see, their docs. We can use access token. And this is data.google service account access token.default.access token. This is correct. So I'm creating a provider Google that I'm going to authenticate using the access token that I'm creating in this data block. And we'll probably also need a provider Google beta, right? So I'll define the same as a provider Google beta, and I'm also going to provide define a Google beta here as well. So this is basically impersonation, right? So this is impersonation in our Terraform code that is done automatically. You simply supply a file called IAM YAML to specify which service account you want to impersonate to. And each folder that we want to impersonate a different service account will place a different IAM.YAML. So if I have a certain section in my infrastructure as code that I want only the DevOps group to access, I'll place IAM YAML with a service account and place permissions to the DevOps group to create access token for that service account. So this is how we can define different impersonation and different section impersonating different service account. Really simple for the user that wants to add cloud resources without need to worry about which service account he needs to impersonate to. So we want to create a section in our project that will be in charge of all the groups and permissions and users assigned to the groups and so on. So we'll create a folder called IAM in our project. So currently in our project we have env folder, which contains like functions to create folder in project, repeatable configurations that we can use. We have common that contains common resources between all that are shared between all the environments. And we will now create also another folder, we'll call it IAM, and this folder will group together everything that relates to groups, permissions, service accounts, And the structure of this folder will contain this entire IAM section will create a GCP folder and a GCP project to hold the entire configuration, cloud configuration for this section. So we will create in the IAM, we will create a folder that will hold, group it together in a folder, everything that relates to the IAM. And inside that folder, we'll create a project and we'll group everything relates to IAM in a folder and in a project. So every service account we will create will belong to that project. And this is not a problem because a service account in one project can have permissions on cloud resources in a different project. So it's okay that everything will be grouped together under the same project. And it's even easier because it's easier in terms of using the log explorer in that project to see everything that relates to service accounts creating resources. So it's quite easy to group them together in a group. There are some advantages for that. And we'll also create a groups folder. Now the groups folder, we will place the different groups we will create. So we might have groups for developers and DevOps and admin and the database admins and different groups describing different team member and the permission it should have. And a team member can be in multiple groups, right? It's not like I'm a developer, but I can be DB admin, or so I can be in multiple groups. So we'll group all the creation of the groups inside a group folder. We'll create also a service accounts folder. So let's create another folder. Another folder for service accounts. So this will hold all the service accounts that belong to this project. And those are basically our cloud service accounts. Those are service accounts that can create resources in the cloud. So those are the only principles that are allowed to create resources in our cloud. No user, no other service account, nobody can create resources in the cloud except the service accounts here. So if you want to create cloud resources, we have to impersonate those service accounts. So we'll create a folder for the service accounts, and the last folder we'll create in the IAM section is permissions and roles. So every permission that we give our groups, so we don't give permission to an individual user, we give permission to a group, and we assign the user to a group. So every permissions and roles that we assign to a group, and permission and roles that we assign for our service accounts. So we'll create another folder that is called permissions. So this will be the structure of our IAM section, which combines all our groups and cloud creation service accounts. And what we'll do now is we can basically start and create the IAM section, and we can start creating the folder and the project. We already have a folder in the env configuration for creating folder and project. So we will use them to create a folder and a project. Okay, so let's start by creating a folder, and we already created a folder. And we created a configuration folder.hcl in env to easily a repeated configuration to create a folder. And we already used it in common. So we created a folder called shared, both folder root and shared. Shared is under root. So we'll take the same logic that we have in shared, and we're going to place it in the IAM folder. And we're just going to modify a few fields here. So this will create the IAM folder. Okay, so the IAM folder is under root. So we have a root and we have IAM folder. Let's leave we'll add the date and additional values later on. So we're including the root Terragrunt. We're including a folder, and we are grabbing a dependency. Since this folder is under the root folder, we will use dependency to get the parent folder. So we need to point to the root folder here. So we are in IAM folder, and root is under common. So we need to go step another back, step to common, step to folders, and root. So this should point to folder's root. And now we're creating a folder. The parent is a dependency of root, and the name of the folder is IAM. So let's save this, and let's try to create this resource. So I'm going under the folder, and I'm doing I'm currently under IAM GCP tofu IAM folder. This is where the file is, and I'm going to run Terragrunt apply. So we'll wait a few seconds to things to be initialized and downloaded, and then we'll see what if the folder is created correctly with the right name and under the right parent. Okay, so let's see what we are about to create. So we are going to create a folder, and that folder should have a parent of, okay, since this folder is pending deletions, because I did create it in the past, so it's a bit of a different message. So let's type yes. Okay, so a folder is created for us, and the parent of the folder is also the root. So we created our folder for IAM. Okay, let's try to create the project. So we already created a similar project. So let's just copy this Terragrunt where we created the common project, and let's go to the IAM project and paste this file. Now, I'm going to use the project configuration that we created to easily create a project. It's going to be under the folder we just created, IAM, and we'll name it not shared folder, but IAM folder. Now this will create the IAM project under the IAM folder. So we'll name of our project Academy's Kubernetes Flux IAM. Now let's try to run this. Under the project folder, I'm going to try and run Terragrunt apply. We'll give it a few seconds to download all the resources, plug in. I'll check that everything is in order and type yes, and then it will probably take a while to create the project. So I will pause the video and we'll return after the project is created. Okay, our next coding exercise is we're going to modify the env folder and add a few repeating configuration. One configuration for creating a group and another configuration for creating a service account. So we have the env file. Currently we have a configuration for creating a folder and a configuration for creating a project. We prefer to use the terraform-google-modules project that is maintained by Google, and we'll do the same to create same configuration, repeating configuration for a service account and for creating a service account in a group. So let's start with a service account, and what we will use is the terraform-google-module service account, which is another way we can use terraform-google-modules for creating a service account. What we need is basically we need the name. Let's see what is required here. We need this, which is the project ID where we want to create the service account. We can place a prefix if we want all our service account to start with a given name. Display name will not be something generic, every time will be something new. Description as well. Billing account ID, if assigning a specify the billing account. So we have a billing account for this project, so we would like to set a billing account ID. So this will be in all our service accounts, so this will be good to add it here. Idea of the organization for organization level roles. We're not going to give any organization level roles. And that is about it, right? So let's try to implement this. I'm copying the project. I'm going to rename it to call it service account. And I'm going to grab the billing account the same way we did in the project, right? So we have billing vars.yaml where we store the billing account. And we are going to use the terraform-google-modules, and it's called service account. We are going to bind it to a certain version. So let's see the current version that we have. So the current version is 4.5.3. So we'll bind it to this version. And we'll start placing some data. One of them is billing account, right? This remains. Let's see, what did we said we need more? Let's say we have a prefix of, let's say, academies, Kubernetes, Flux. Let's make it shorter, academies, Kubernetes. And the names is different, the project ID is different, the billing account we have, the prefix, and that's about, I think that's about it for the service account. So let's save this. And let's create now the group. So let's copy this and create another one for creating a group. So let's see what the groups need. Again, we're using the Terraform Google modules. Now, the group needs a customer ID. Customer ID of the organization, the grade of this is not required, but you either need to specify this one of domain or customer ID must be specified. So we will add a customer ID. Now the customer ID we will place in common vars. Customer ID. Okay, so the way you get the customer ID, so a customer ID is attached to an organization. So you can do gcloud organization list to see organization, and you see on the right side the customer ID. So that will be the customer ID, and we will, it's called group. The current version is 0.70. Let's bind it to a version. And let's see if we have additional things to place in the input description, a specific display name, domain. We specified the customer ID. ID is required, but it's different. Must be the email address of the group. So this will be different from group to group. So managers, members, owners. Owners we can actually specify later on when we create the service account for IAM. We can set this as owner in all our groups, but let's wait for this for a while. And yeah, that's it for our groups. So we'll just specify customer ID. And yeah, and that's it. This is a Terragrunt function to create a group. And what we created before is a Terragrunt function to create a service account. Awesome. We now have these two functions which we can use to create groups and service accounts. So actually examining the docs again, the billing account is if assigning billing role. So we don't really need the billing account, at least not for the default one. So for the default creation of every service account, because only service accounts that are assigning billing account roles will actually need this. So we'll delete the billing account, and we can delete from the locals the billing account. Okay, great. Now what we're going to create is we are going to create one group for admin users. And the goal of the admin users is that they are the users that are allowed to create groups, assign members to groups, create service accounts, and assign permissions and roles to the groups and service accounts. Basically, they are in charge of the IAM section of our course, of our cloud resources in the course. So every new user the admin can assign that user to different group, and the admin can give that group permission and service account. So this is the admin group. So this is a very powerful group. Very few members will be in this group, but almost all organization usually has this kind of group, a group that usually assigned to team leaders in the DevOps or team leaders in DevOps or team leaders in general or CTOs. It's a really small group of people with a very powerful role. So the admin will create admin group and IAM service account. So, and the admin group is the group of users that can impersonate the IAM service account. And the IAM service account can create groups, can create other service accounts, and the IAM service account can assign roles and permissions. Now, they can assign role and permissions, but not to the entire organization, but rather to the folder of the course of the project. They're not, they don't have all the power of the organization. They simply have the IAM power over the entire course resources. And as we said, the IAM service account can assign roles, everything within the IAM folder will be created using impersonation to the IAM service account. Now, what this means is, that what we will do is basically what we'll soon do in this next coding exercise. We are going to create a group that is called admin. So we're going to create this group, and we are going to create a service account. So we didn't create in the IAM, we're going to create service accounts. Nope, I have it. So it's in the last. So we're going to create a service account that is called IAM. We're going to assign permission to the IAM service account that they can have, they can create other groups and assign members to the group and assign roles. And everybody, the people that are allowed to change the IAM section in our in this infrastructure code project are only users. We're going to create IAM.YAML file with an email of the service account that we're going to create. So only group members of the admin can actually change the IAM. I'm going to delete this. We're going to create it after we actually create the service account. But this is our goal in the next coding exercise. Okay, let's start by creating the IAM service account. So I will go to, and I will use the service account configuration that we created in the env, and I will go to IAM, I will go to service account, I will go to IAM, and then in here, I am going to place a terragrunt.htcl file. Okay. So this will, I just copied another terragrunt.htcl file. This will create the IAM service account. Okay, so we're including the root. We are going to grab a dependency. Okay, so if we go to the documentation of service accounts, so I see that I need to provide a project ID, and I need to provide the name of the service account. Now the name is an array of names if I want to create multiple service accounts. So I will create just an array with a single service account that I want to create. So I will have a dependency for the IAM project. So the IAM project is, if I'm in the IAM service accounts, IAM, this is two folders back and then project, because the project is in the IAM folder. So I will have two folders back and the directory is called project. This will grab the IAM project, right? So this is the IAM project. Now I need to supply a few inputs. I need to include the env of the service account that we created. So I will include, I will call it IAM service account. And the way we include, so let's see an example that we have in the project. So the way we include is by using this. So we're going to the env and we will go to service account.htcl. So this will include the service account configuration that we created just a minute ago. So after this configuration requires those inputs, right? So it requires names. So I'll place the names. So the names is going to be IAM, and another it's require project ID. So dependency IAM project outputs project ID from the dependency here. This should create us the service account that we want. So this is an empty service account with no roles or permissions attached. Okay, so let's go to the folder here. And let's do Terragrunt apply. And I'll give it a few seconds. I'll cut the movie here. I'll give it a few seconds to create the service account, and then I will continue the video. So we successfully created the IAM service account. And this service account is the service account that will be in charge for the entire IAM folder, the entire IAM project that we have in our application. And that project will be in charge of creating other service accounts and creating other groups and giving application permissions for those service accounts. So from this authoritative service account, we can create, for example, the DevOps service account for all our DevOps team. We can create a developer service account with a developer group. And it can also assign our team members to the different groups. So basically we have kind of like the super service account that can create groups, service account, assign members to those groups. And this will be the start of every group we have in our application. Every team member will be assigned to group. The permissions will be assigned. So, and to give permissions to the service account IAM, we will use, again, terraform-google-modules whenever we can. They have a good module called terraform-google-IAM. And this module will enable us to give permissions. For example, it looks something like this. You can set a permissions on a project by using the terraform-google-modules IAM using a submodule called projects IAM. This will provide, this will allow you to assign roles for a project. So we have roles, in this example, role storage admin on a project, on those two projects, and assign a group and a user, and a network admin for those two projects. For example, you can also use the submodule storage buckets IAM to assign roles on a bucket. So in here we have the user Jose Manuel that has permissions, storage, legacy bucket reader on this specific bucket. And there are two modes that we can run it, which are also very important in terms of security, because we can do something called authoritative. So authoritative, what we'll do, it will do a binding of those of this specific, for example, role to those user, meaning it will remove other groups, other user, and have this to be the source of truth of the role legacy bucket reader. So we kind of control this specific roles and assign it only to the user and group. And this is great for cases that we want to limit who is able to have a certain role. We'll use it a lot when we want our Terraform project, we want our Tofu project to be in charge of a certain role, so you will add a binding for that role, mode authoritative, to only allow certain user and groups. This is great for security and disable the ability to add this role to users to principals that are not in this group. So to use this module, we will add it also to our env, right? So we have our env section that has all the repeating configuration, and what I'll do, I'll add something I did before and just copy paste it. I will add in the env IAM section, which what it does, it takes the Terraform IAM Google, the Terraform Google module that we just saw, IAM, and just set billing accounts for IAM for role, to set roles for a billing account, folder to set role on the folder, project to set role in the project, service account to set roles on a service account, and storage bucket to set roles on a storage bucket. This way, every time you want to assign roles to one of those one of those GCP resources, we can just use the .env IAM. If we want to set a role on a storage bucket, we will use the env IAM storage bucket. And this is how we will use, and this has more modules, right? So you can go here and you can go to the documentation and you can see the list here. It has, if you can add more of those configuration. For example, if you need to add permission on organization, so we have project already, organization, I didn't add, folders, we have service account, we have subnets, I didn't add, but if you need, you can add additional to the additional env IAM. Pops up topic, pops up subscription, all of these are submodules of the IAM that you can use to add permission. Now what we'll do, we'll use these configurations to give permissions to the service account that we just created, the IAM service account. Great, so now that we have our env IAM configuration that we can create with them, we can create permissions. Let's start with adding the permission to the service account we just created, to the IAM service account. So we have the IAM service account, we have the permissions folder where we have all the GCP service accounts that we want to create. We'll give permissions in this folder. So we'll arrange it by creating a folder for the service account we want to give permissions for. So we want to give permissions to the IAM service account. So we'll create an IAM folder. And I want to start by creating the first permission because the IAM service account is a service account that is in charge of giving permissions to other service accounts. So what it needs to have is the security admin role. So what does the security admin role does? We can go to the GCP, to the roles, to the permission roles section. We can search for a role and we can see on the right the permissions that this role has. So basically what this role has, it has a bunch of list permissions. So for example, the different services that GCP offer, it can list them. So you have a lot of different services, it can list them. You have a lot of list permissions. It does not have permissions to use or create in those services, just to list them. And the other permissions that we have are IAM policies permission, get IAM policy, set IAM policy. So basically this is a very powerful role that allows to set permissions on all the GCP services. Now, the question is not just what minimal role I need, but where to assign this role on. So I can set this role, for example, on the organization, which will be very powerful. Whoever has this role on the organization can pretty much do whatever he can because he can set permissions, right? So he can, if a user has this role in an organization, it can set himself permissions to do whatever he wants and he can do whatever he wants. So I won't give it on the organization. So just to understand how powerful the IAM service account is, very few people in the project are going to belong to the group that can impersonate this service account. So this service account is very limited. Very few people, maybe the CTO, maybe team leaders or team lead or someone that needs that permission will be maybe the team lead of DevOps, certain DevOps. So this is a very limited group, the IAM. This is a very powerful permission. And what we'll do, we won't give it on the organization, because we will give it on our entire application, on all the projects we have in our infrastructure as code, in this course. So all this course is grouped together under common folder, under a root folder. So we have one folder, and this is why the folders are so important. It's important to group similarities in a folders, because then you can assign permission on the folder. So what we'll do is we'll assign that permission on the root folder, and it will allow every resources in the project, every other folders, because everyone is grouped under the root folder. It will allow the IAM service account to assign permissions, policies to everything under the root folder. So under permissions, we will create another folder that is called root folder. And in here, we are going to, let's add a terragrunt.htcl file. What we'll do in this file, let's place everything in remarks. This file, the root folder, this will assign IAM permissions to the root folder of the course. Okay, so we're including the root. We are going to include the IAM permissions. So we're going to include, let's say, IAM folder, the env IAM folder.htcl. So in here, we are basically using the env IAM folder HCL that we created here to assign IAM permissions on a folder. Now to do that, we need a dependency, right? So we need a dependency of our root folder. Now our root folder is inside here, right? So common folders root. So I will basically, and I am in here in the root folder. So so I'm in the root folder, and I need the dependency from going one folder back to IAM, one folder back to permissions, one folder back to IAM, one folder back to the root, and then common folders root. Hopefully this is the right path, right? And what it does, it will grab an input that the folder HCL requires, right? So we have the folder HCL, maybe I have it here. Here in an example folder, so here folder IAM. We have an example of folder, and we are going to place what folders do we need? So let's place the input of folders. Folders, it gets an array of folders, so we'll place here the dependency root folder outputs ID. I hope it's correct. We'll also add a mode, not the mode additive, but the mode we said that it's either additive or authoritative. Authoritative is creating a binding, so this means that the roles I place here are only can be assigned here. I can't place the role security admin in other places. There is a binding, there is a source of truth between this role and the groups here. Okay, so what else do we get? We get the bindings themselves of the roles. So let's add this. Bindings. The bindings is an object. It gets the role. So we want the role that we said, role security, IAM security admin. And the role security admin, it gets an array with the principals that are allowed to have the security admin. And since I placed authoritative, only this list is allowed to have this role. So this is great because this is such a powerful role that I want to make sure that only the principals in this array will be allowed to access this role. So what I'll do, I'll grab whoever has this role as a service account, right? So I'll have a dependency of the IAM service account. The IAM service account, it's not that far. The IAM service account is in the IAM folder under service accounts IAM. So one folder back is the IAM, another folder back is the permission, another folder back is the IAM, then service accounts, then IAM. Now the bindings here, I will say that the bindings here has a service account of the IAM service account, output service account. I don't think that service account email. I think it's just email. I will check it soon, but the easy way to check it is just we can go to the IAM folder where it's created, and we can open a terminal here, and we can simply do a Terragrunt output to print the output. I'll do it soon and then I'll correct it if it's not email. I think it's email. So this is the binding here. Let's see if we need anything else. No, that's about it. This is what we need on the root folder. We need to place the role security admin for the service account we just created for the IAM service account that we are grabbing from a dependency. I'll try to run this. I'll correct any errors that I have if I grab the wrong output or grab the wrong path here, something I suspect that might happen. So I'll correct this if I have any bugs and run this code to see that everything runs correctly. Great, so our code worked and we were able to add the role security admin to the root folder. So the IAM service account, which is the service account that is in charge of creating groups, assigning members to group, creating service accounts, that those service accounts have different GCP permissions, and creating impersonation to those service accounts. So the different users in the different group can impersonate service account that they can create various GCP resources. So our root folder security admin role is assigned to the IAM. What we're going to do now is our IAM service account can create other service accounts. Those are the service accounts that we let users groups impersonate to, and they can create different GCP resources. So I need the IAM service account to be able to create service accounts. Now, where would the IAM service accounts, where would all those service accounts belong to? They will belong to a project, to the IAM project. So all the service accounts that are in charge of creating GCP resources will be created in the IAM project. So in the permissions IAM, I will add another permission for the project, I will call this folder IAM project. And this will include permissions. I will add here a Terragrunt file. And this file will, this Terragrunt file will include permissions that we give to the IAM project. And the permission we will give here is permission to generate service accounts inside the IAM project. So this is what we're going to do now. So we are going to include the root. We are going to grab the dependency of the project that we want to assign the role to. So we want to grab the IAM project that is located here. So I will add a dependency for the IAM project. And the dependency will have a config path to the IAM project, which is located one folder back. We are currently in the IAM project, so one folder back to the IAM, one folder back to the permission, one folder back to IAM, and then project. So 3 folders back, and then project. Great, so we grab the dependency. Now we are going to include, we have in the end, we have the IAM section that we added, and we have permissions for a project. And this is exactly what we're doing, right? We're giving permissions to a project. So we are going to include this project HCL. So we have similar that we did here, include IAM folder, only we will change this to include IAM project. Oh, we already have IAM project, and include, let's call it IAM, and it will be to the project.acl, the IAM project HCL. Now, this will get different inputs that we will mention here. Now, this module, the project HCL that we have here, is the Terraform-Google module IAM, that this is what we recommend to use for assigning different roles to different services, rather it's project or folder or bucket. And inside it's usually using the modules.project.iam, which we have here. So this is the different, this is the documentation of that module and the different inputs that it accepts. So for project, which project are we going to assign this role to? So this is easy, right? Because we have the project, the IAM project here. So for projects, we are going to use the dependency IAM project outputs. I hope it's ID. Might be project ID. Might get an error on that, so I'll check it later. The mode we are getting, we have mode that is additive, to add permissions, or the mode that is inclusive, which this is what we want, inclusive, which is authoritative. So we'll add the mode authoritative here. Now, the actual roles are in an object which is assigned to the bindings here. So we'll add bindings, and we'll add a permission here. Now, which permission are we looking for? We are looking for a permission that is called IAM Service Account Admin. Remember, we need a permission to create service accounts in the project. So this is what we're going to do. We're giving permissions to create service account in the IAM project. So this permission here, service account admin, enables us to create service account. And we need to assign it on the minimum place that we want to assign those we want to assign this role, which is the project itself, the project IAM. So another dependency we'll need other than the IAM project is the IAM service account, which we already grabbed in the root folder. So we might as well just copy paste this. This is the IAM service accounts, which I think the path is correct as well. So the bindings that we'll add here, we'll add a role that is called IAM security admin. And for this role, it gets an array, and it gets who is assigned, is allowed for that role, which is our service account. Great. So this is our code that assigns a role service account admin on the IAM project here. So this will allow the IAM service account to create different service accounts inside the IAM project. So we'll try to run this code and create this permission, and we'll see if everything works correctly and move from there. So the permission role IAM service account admin is successfully added to the IAM project. I did have to change from ID to project ID because the output, the project ID is not under ID, it's under project ID, but after that it's fixed, everything ran correctly. Now, our IAM service account is also in charge of creating groups. So to create groups, we need to set some permission on the billing account and on the billing project, because the API that is creating the groups will use some APIs that relate to the billing account and billing project. So we will have to set some permissions in the IAM, and here we'll create a folder called billing, let's name it billing project. And it's going to be very similar. I'm copy the Terragrunt HCL to here. Okay. And what we will need to place on the billing project is the role service usage consumer. Why is it? Okay, service usage consumer. And this role help us. It's a certain thing that relates to API that's going to be called when creating groups to know the usage, to the quota, the money to charge, stuff like that. So this will be a role that we will place on the billing project. So we have the billing project inside our billing vars.yaml. So all we have to do is read those billing vars using the locals like we did before. So using the locals, I can read the billing vars. Let's name it billing vars is equal, and I don't recall how we are doing this. Let's go to the root Terragrunt file. We call here the billing vars, and we'll do something similar here. Oh, I lost it. Terragrunt locals and then billing vars. Okay, so locals and billing vars, and then the billing project is locals billing vars.billing project. Now we have the billing project that we read from our billing vars YAML, which is a constant that represents the stuff about the billing that connects to our course. So when you create a project, you need to pay it, you have to attach it to a billing account. So now that I read the billing project, I don't need the dependency of IAM project. So I do need the dependency of the service account of IAM. And I do need to include, because I'm placing this on a project, so I do need to include the project HCL, the end that's going to add the permission. And in the project, instead of the dependency here, I'm going to place local.billingProject. Great. The mode, I'm not going to do authoritative, but I'm going to do additive, because maybe other projects also want to attach stuff to that billing project. So I'm not going to do it inclusive. I just will add a member. And what I will do is I will add the role service usage consumer to this project. And also attach it to the service account. Okay, so that's one permission that we'll have. Another permission that we'll have is on the billing account. So in here, I will create, in the permissions, I will create another folder called billing account. And in here, I'm going to paste Terragrunt here as well. Now, it's not the billing project that I need here. I need here the billing account. I think it's this. And we are going to add the billing account, the permission for, that's called billing admin. That we need this also for payments and such, because the group's API is using it in terms of know how much to charge and all. So I am going to place this role here, the billing admin, attached to the service account. And instead of using the project HCL here, I am going to use the billing account, this one. Billing account. Now the billing account is a different module for permissions that I have here. It's collect the billing account IDs. So instead of project, we have billing account IDs. Mode will be additive. The role is here. The role is pretty much similar. It's to our service account, and that's the final permission that we need for the IAM service account to start creating groups. Now I'll try to run both of those Terragrunt files to see that everything works and we added the proper permissions. And then we'll try to create our first group using impersonation to the IAM service account. Okay, so we managed to give the proper permissions on the billing account and on the billing project. On the billing account, we gave the role billing admin, and on the billing project, we gave the role service usage consumer. Now what we're going to do is we're going to use our service account to try and create a group. So what I will do, I will go to the IAM and I will say everybody in this folder that is executing any Terragrunt command within this folder, I want that user, before it creates anything, to first impersonate. Impersonate the service account that is the IAM service account that we gave permissions to, right? So we gave permission to a service account that we created for every IAM thing that we need to do in our project. So I want to do impersonation. So remember that in the root Terragrunt, we created impersonation logic based on a file called iam.yaml. If this file exists in a folder, everything under that folder is by impersonating the service account that is specified in this file. So what I'm going to do is going to the IAM, and I'm going to create this iam.yaml file. So I'm going to create this iam.yaml file. And in this file, we are expecting an email of the service account that we want to impersonate to. So I'll specify an email, and the email will be the IAM service account. So basically the service account IAM that we created here. So I can go to the infrastructure as code folder, GCP, tofu, IAM, and then go to the service accounts, and then go to the IAM service account and do a Terragrunt output. And I'm going to grab the email, and this represents basically the email of the IAM service account. So what I did is went to this folder here, IAM, and did a Terragrunt output to output the email account of our service account that is in charge of IAM. So this is our service account here. I'll take this and I'll paste it in the email. Now basically what I did is I said that everything under the IAM folder, the service account that is in charge to create anything under the IAM, everything under the IAM folder is the service account that we created for IAM. So now let's try to create a group. We managed to create a group. Basically what we said is the person that has created the group is our service account, which is great. This means that our service account has the proper permissions to create groups. And what I will create is the admin group, the group that is in charge to impersonate this powerful IAM service account. So all the users that I place in the group admin can impersonate the service account, and basically what they can do, they're a security admin, meaning they can create service accounts, they can assign policies, roles to that service account, they can create groups which impersonate those service accounts. Basically that is the group that is in charge of saying which developers are in charge, belongs to what group, and what are the permissions for those groups. So now I'll create, in the group file, I'll create a terragrunt.hcl file. Okay, so what I'll do here is I am going to first include the root, right? Because we basically place it everywhere. We first include the root logics. The root logic also include provider definition and also include our impersonation. And what I'll do now is I am going to also include in the env, we also created a group HCL as like a function for creating groups, which is basically using the terraform-google-modules module to create group. So in here, I will add and include in the admin section, in the admin group, I will create include for the group, which will execute the group HCL file. Now let's place the inputs that we need to create our group. And to create a group, we can see the inputs are in the group HCL. We are using terraform-google-module group Google. So we can go to the documentation of that module. Now before we can actually create group, there is an additional step that we need to do. And we need to go to the admin.google.com, because creating groups are from a different API. It's not from GCP, it's from Google admin. So we'll have to go to admin Google group, and we'll have to go to admin roles, and we'll have to go to group admins. And in here, we will have to assign admin and place the service account that we created for groups, meaning the service account, the IAM service account. We will have to add it in the admin.google.com before that service account can create groups. So we need to give extra permission in the admin.google.com before we can use a service account to create a group. So I already did this, and now so we can create use the module to add additional fields. So we'll add the ID field. So we'll go to our admin group and we'll add the ID field, and the ID field will be Kubernetes Flux, and we'll call this the admin. Okay, so this is one field, the name of the group that we want to add, and we have the display name. The display name will be let's say the display name will be Kubernetes Flux admin. Another input we need is description. The description will be Kubernetes Flux admin group. That's fine. And the domain is academies.com. I don't think it's required. The owners, the owner of the group. So I created empty user without any permission that is called Kubernetes Flux academies.com. The reason I created this member is so I can test every permission, the permissions that we provide here. Basically, this is a user with no permission at all. So basically, if he can impersonate the IAM service account and start creating groups and assign policies, this means it works. Basically, we created user that can impersonate without, and using the impersonation has additional powers to create additional stuff. So this will be the owner, and it will be also a member. So we'll add a members. He will be the only member of the group. So that's it. That's the needed, I think this is all we need to create a group. Now what I'll try to do, I'll try to run this code and see that everything is working, and we managed to create a group using impersonation. So we managed to create the group of admins, a group where we're going to place members, that those members will be allowed to create other groups and assign policies to those groups. And in this group, we added a member of, I created a brand new member with no permissions, just to check that we actually are giving the right power to a new user. I had to do a bit of change. I removed the owners, because owner already adds a member. So you can have an owner and a member with the same email. You can have, because owner is already owner and a member. So I just kept the new user as a member. Now, this group doesn't really have anything attached to it. This group cannot actually do anything. So what we want to do is the IAM groups that we're going to create, we want to allow them impersonation to service accounts, to certain service accounts that has powers over resource creating in GCP. So I want to allow this group to have impersonation on the service account. So for this, we're going to add the role IAM service account token creator, and it's very important to add this role on the service account that you want to impersonate. I see this mistake often, that this role, which is a very powerful role, is assigned on an organization or a project. It really has to be specific and be assigned to the service account that you want to impersonate to. I also did this mistake. So in the IAM, I will go to assign permissions to the IAM service account. We have it in IAM permissions, and in here we have IAM. So I'm going to create a new folder called service account. And in this service account, I'm going to create a Terragrunt.hcl file. And in here, we're going to first include the root. And then we're going to have a dependency of the service account, grabbing the service account that we want to assign a permission to. So the dependency service account, this is not correct. To grab the dependency service account, let's see, dependency IAM service account, you have it here. So it's going 3 folders back, 1 folder back to the IAM folder, 1 folder back to the permission, 1 folder back to the IAM, and then going to the service accounts IAM. So this is how I take the dependency IAM service account. And I am going to include IAM for creating a service account. For this, we have in the env folder, we have the IAM that will add policies, and in here we have a policy to add to a service account. So we're going to simply use this terraform-google-modules that add IAM policies to a service account that we already created. So we just need to include, let's call it IAM service accounts allow, let's say. So this is going to be in the env folder, in the IAM, in this service account HCL. So this seems correct. So let's add the proper inputs. So to place the proper inputs, we need, so this is the service account. So this is the terraform-google-modules service account. Let's go to their documentation and examine their inputs. So let's see here. So they have here the service accounts. Where is the service accounts? Service accounts IAM. And here is an example. So let's add a service account that we want to impersonate to. So in here we have the service accounts that we want to impersonate to, which is the IAM service account that we took as a dependency, the outputs, the email, and we have a mode that we want. The mode is either restrictive, authoritative, or additive. We create authoritative because we want only this group, only the admin group to be allowed to create to impersonate that service account. So we're really restricting who can impersonate that service account by using this mode authoritative. So it also is very important. And we'll add the proper bindings. So bindings, and in here we're going to add the role that we said, which is the IAM service account token creator. And in here, we are going to add our group. Now, we need to also grab as a dependency the admin group that we created, right? So I can go to I'm currently in the directory of the group's admin. I can do a Terragrunt output and grab the email of that group. Let's not grab the email, maybe it's, so grab the ID, I think. No, let's examine the output, the full output. Okay, so it is ID. So I'm going to grab as a dependency, the admin group, which is maybe 3 folders back, could be. IAM permission 3 folders back is to the IAM, and then groups 3 folders back is to the IAM, and then groups, and then admin. Seems about right. And in here, I will use this dependency to attach the role to this group. So every member of this group will have this role that it can impersonate, and it can impersonate this service account that provided here, which is the IAM service accounts. So that's about it. We will try to create it and see if we manage to attach the service account token creator to the admin group that we just created. Great, so we managed to place a role called service account token creator on the IAM service accounts. I had a bit of a bug that I had to add also a project. So I included a dependency of the IAM project, the project that the service account belongs to, which is the IAM project. So I took it as a dependency and added the project here. Now, what I did, as we mentioned, we created an empty user, a user with no permission. Until now, I used a master user to create all the architecture of the permission and roles. I needed a really strong user. But from now on, I can stop using that user or reduce the permission of that user. And we can start using a very minimal user to see that everything is working. So in the admin group, I already created a user called Kubernetes Flux with very minimal permission. And I logged in as this user. So now I'm running Terragrunt as this user here. So what I want to see that if I have this user, which I'm logged in and running Terragrunt from this user, that this user can impersonate the IAM service account. And basically is getting all the permission the IAM service account is getting, which is create groups, assign members to groups, assign policies. So what I want to do is I want to test it by creating a group. So let's create a group additional group called DevOps. So the DevOps groups is a group that my DevOps team will be there, and they can create things in certain things. They can create, for example, maybe database or Kubernetes clusters, and they can create them in certain projects. They can create projects under the root folder of this course. So this is the DevOps team. And what we'll do is very similar to the admin team. We're going to take the Terragrunt HCL of the admin group, creating the admin group, and do something very similar with the DevOps group. Include the root, include the group that we have in M for the function that we have to create a group, and assign the ID, let's say Kubernetes Flux DevOps. Display name will be Kubernetes Flux DevOps. Flux DevOps groups. And the member of this group, I will add the empty user as a member of this group as well. Basically, the empty user is like our guinea pig that we're going to test the permissions. So I'm going to assign the member also here. Now, if everything works correctly, I will be able to create this group using a very minimal user here that can impersonate a very strong service account. So let's try to run this code and see if we manage to create a group successfully. So I tried to create a group with a brand new user I created that has no permissions on our GCP, and I tried to create a DevOps group, and obviously it failed. And the reason it failed, I couldn't actually run with this user, I couldn't run a Terragrunt command because in the root Terragrunt, we are storing the remote state inside a bucket that is called Academy's Kubernetes Flux Terragrunt state. So in order for a new user to run Terragrunt command, that user needs access to the Terragrunt tofu terraform state bucket. So in order to do that, what I'll do now is I went back to the powerful user that I used before, and I'm going to the groups, and I am going to create a group that is called Terragrunt. And the group that I'm going to define in the Terragrunt, I will give permission for this group. Every member that is in this group can access the bucket in Terragrunt that we store the state. So let's create the group. So I'll go similar code to how we create the DevOps group. I'll go and place a Terragrunt HCL file. I'll include the root. I'll include group, the group function that we have in env. But I'll create now a Kubernetes Flux Terragrunt group. And this group is, let's change this to Terragrunt as well. And all the members of this group can access Kubernetes Flux, Terragrunt bucket. This group can access the bucket that Terragrunt is holding the state in. Now I'm going to place a member, but I'm not going to place a member of an individual developer. Rather, I'm going to place our admin groups. So I am going to go to the admin group that I already created, and I'm going to take the ID of the admin group, and I'm going to place it as a member. So everyone in the admin group can basically access this, this bucket. Now, if I want to be a bit more organized, I can take this as a dependency of the admin group. And the dependency of the admin group, let's see, the dependency has a config path, and I'm going to place it to route it to the admin group, which is one folder back and the admin. And then in the members, I am going to place dependency admin group outputs ID. Hopefully it's ID and not email, but I'll run the code and then I'll see if it works or not. So I can place in the members, I can place entire groups. So basically I'm saying everyone in the admin group can access the Terragrunt, the Terragrunt bucket. So I'll try to run this code and see if I haven't done any mistake and see that our group is created. After the group is created, we need to give that group permission to access the Terragrunt bucket. We need to give it storage admin. So let me run this code, see that everything works, and then we'll give the Terragrunt group permission to access the Terragrunt bucket. Okay, so the code worked and we managed to create a group that is called Kubernetes Flux Terragrunt. And everybody in this group, which is at the moment we only place the admin group. So all the members in the admin group can basically access the Terragrunt bucket. But before they can actually access the bucket, we need to give permission to the group. So we need to give permission to the group of roles storage admin, so they can access that bucket. But we need to give this role storage admin not on the organization, not on a folder, on the actual bucket that we want this group to access. So we're really taking into consideration what the minimal element that I need to actually place the permission on. So I'm going to place it directly on the bucket. It's really important to fine tune and give the permission to the minimum places that you can give it. So for doing that, I am going to go to the folder where we give permissions to group and service accounts. I'm not going to create a service account for the Terragrunt. This group can only access the bucket. So I'm going to go to the permissions, and I'm going to, we already have an IAM folder for the permissions we give to the IAM service account. So I'm going to create a new folder that is called Terragrunt, that this is the permissions that we are going to give to the Terragrunt group. And in here, I'm going to create another folder called state bucket. This is the permissions that we are going to give on the state bucket. The permissions is I'm going to use one of the env files that I created that is called storage bucket that can directly place permission on a bucket. So it's really important to understand what elements you can place permission on. So you can place the minimum permission. So you can place permission on a storage bucket, on a service account, on a folder, on a project, and really choose the right one. So we're really placing the permission directly on the storage bucket. So I'm going to place the permission on the storage bucket. I'm just going to take one of the Terragrunt folder of the permissions that I created before. So I'm going to take this one, and I'm going to include the root. I don't need the service account, but I do need the dependency of the Terragrunt group that I created, not the admin group. So groups, let's go to Terragrunt. Great. And I am going, we're going to use the terraform-google-modules storage bucket IAM. So for this to work, we need to say the storage buckets that we're going to place. I think maybe it takes also a project, no, just storage buckets, and then the bindings of those storage buckets. So let's use the include the IAM, the HCL file for the storage bucket HCL, storage bucket HCL, and this will include bucket, let's call it bucket permissions. I don't need the IAM service, the IAM dependency. So now all we need is to add the inputs that we need to add to the storage bucket IAM. So I am going to place the storage buckets in this. So the mode will be additive, not authoritative. Additive because I don't want to control the storage bucket and only allow the members here. Maybe I want to add other members. That's not in this code, so I'm going to place this as additive, and I'm going to place the storage bucket. And the storage bucket, we know that it is referenced in the root Terragrunt, so I'll place the storage bucket here. And now I'm giving the roles under bindings. So in here I'm giving bindings, and I'm giving the proper roles. So I'll just, let's delete those roles. Just add the role that we want. The role that we want, we said it's the storage role, storage admin. So let's take this role and place it here. And here I'm going to place all the members that I will give this role to, which is my group, right? So I'll place group and place dependency admin group. Actually, it's not a admin group. Let's call it Terragrunt group. And that's pretty much it. We give the role storage admin to the Terragrunt group that we just created. I'm going to try to run this code and see if we manage to give the right permission to the Terragrunt group. And by giving it to the Terragrunt group, we actually also gave this permission to the admin group, because in the Terragrunt group, we have a member of the admin group. So basically the admin group, I have in the admin group, I also have the member Kubernetes Flux that has no permission that I'm trying to run the code with. So basically I'm giving this member here the role of allowing him to access the Terragrunt state bucket. Great, so we managed to give the proper permission for the Terragrunt group to access the Terragrunt state bucket. And we also placed the admin group to be included in the Terragrunt group. So this means everyone in the admin group has permission to access the Terragrunt state bucket, which means I can now try to identify as a user called Kubernetes Flux, an empty user I created with no permission at all. The only permission this user has is the fact that this user is assigned to the admin group. So it is part of the member of the admin group. And the only permission the admin group has is the permission to impersonate a service account. So the IAM, the admin group, has permission to impersonate, to create a impersonation, to create a token, and to impersonate a service account. So the admin group, so basically our user has the ability to impersonate as the IAM service account. And if this is correct, this user, which is only belonging to the admin group, is now able to create a group. So let's see if it works with the DevOps group. So I'll go to the DevOps again. We tried it before and it failed because the user that I created did not have access to the Terragrunt state bucket. Now that we fixed it, let's open the terminal inside the DevOps group, and let's try to run Terragrunt apply and create this group. Okay, so I'll try and create this group. I'll pause the video, try and create this group with a user that belongs to the admin group with no other permissions. And if it worked, then basically I now have an admin group. I can add members to this group, to those group, and every group of those members can create service account for GCP, for the IAM project, to create resources in GCP, can create impersonation, can set policies. So basically those are the start. Those admin users can create other groups, assign members, and pretty much control all the aspects of groups, permissions, and users in our project. So we managed to create the group of DevOps. Now the rest is just, we have the IAM structure, architecture. And the rest is simply creating different groups according to my organization needs, and supplying each group the minimal permission that it needs placed on the minimal elements like folder or project. So we created a DevOps. Now we can create a service account for the DevOps. So the DevOps can impersonate a certain service account and create only the resources that they need. So similar to the IAM service account, I'll just copy the Terragrunt and I'll create a new folder that is called DevOps. And DevOps we'll have a service account. We'll create using the service account .hcl. We're going to grab the IAM project, so it will create the service account in the IAM project. So every GCP creating service accounts are belonging to the IAM project. And we're going to name this as DevOps. And we will create this service account. After this, we will go to permission, and we are also going to provide permission to the service account. So inside the permissions folder, we are going to create a DevOps folder to give permission to the service account of the DevOps. Now permission, it will have billing account and billing project, because they will need those queries when creating certain, when activating certain APIs. The DevOps will need those as well. So I'll delete everything here except the Terragrunt file. So the billing account is going to take the billing vars and the billing account, and it's going to grab the service account of the DevOps, and it's going to go to the billing account and add the billing admin to the service account of the DevOps. So maybe it should be DevOps service account here. Okay. And similar with the billing project is also going to grab the DevOps service account and also the IAM for the project, and create a service usage consumer for the DevOps service accounts. And we will also probably have a few permission on the root folder. So let's copy this as well. So for the root folder, I'm going to grab the root folder. I'm going to grab the DevOps service account. By the way, I didn't change here in for DevOps. I will grab the DevOps service account, and then I will give him certain permission, not security admin, but for example, we can give, let's say, project creator, because the DevOps will probably need to create project inside the root folder of the entire project. So I am going to place project creator. And of course, I can remove this if they don't create projects, or but in this example, let's say that they do create projects, so I'm giving the root folder here. Also, I will need a service account, because what I will need is impersonation rules, an impersonation rule to allow the DevOps group to impersonate the service account. So I will take the DevOps service account. I will take not the admin group, but the DevOps group. And I will allow the DevOps group to create service account token creator to impersonate the DevOps service account. And yeah, that's pretty much going to repeat with each group that we create. So now you have the power, the architecture to create groups, assign members. You don't need to give members of your team owner permission or something very robust. Just place them in the right groups, give that group the minimal permission. A lot of the lessons that we'll create will talk about the permission that you need to assign to create that resource. So it's really important to try to organize the groups in the organization properly from the start. So I'll try to create all those resources for the DevOps group, see that everything is working, and let's summarize after that, summarize the lesson and talk about all the things that we learned regarding permissions in this lesson. Okay, so our test worked. We managed to create a user with no permission, just assigning that user to our admin group, and that user successfully created the DevOps group, created the DevOps permissions, created the DevOps service account. I did have some problem creating certain permission in the DevOps, specifically the billing project. The billing project, and the way I arranged this, the billing project is academies, which is outside the root folder of this course. So I had to set special permission on the billing project. So in the IAM in the billing project, I set permission security admin. Usually it won't be a case because your billing project will be inside the folder of your project, the root folder. And usually the permission that I set on the root folder, security admin, will be enough. So this is only an exception in this case, since my billing project is outside from the root folder. So, but everything works. I can now, every time I get a new user to my organization, I can create a group of developers for the developers, assign them certain permissions, create the DevOps certain permission. It allows me to also show you in the lessons what permissions and roles you need to create the resources in the lesson. So it's going to be really effective, because I noticed that a lot of lessons online, they just show you the Terraform code, and when you try to run it, it actually doesn't work because you don't have certain permissions. So yeah, I wanted to show you how we manage principle of least privilege, how we manage security, how we manage groups and impersonation, and the architecture of it all in a project and infrastructure as code project like Terraform or OpenTofu or Terragrunt. And I wanted to show you how I do it. I used to do the mistake of setting a lot of developers as owners and give them a lot of permissions, and this has stopped, and now I'm doing an infrastructure like I showed you in this lesson. Yeah, so this is it. We managed to follow the principle of least privilege. We give the minimum permissions to our users, to our developers, and we can create groups and give them minimal permissions and not give those basic roles like owners or viewers, those legacy roles that you should stop giving. The only person that is allowed to create GCP resources are service accounts. So users cannot go to the web UI and create resources. This means that we are pretty much forcing our infrastructure as code project to be the source of truth for our cloud infrastructure, which is great. We have no developers going rogue in the web UI and starting creating different resources that we cannot track. And what we're doing, we are using impersonation to give, if I'm giving user permission to impersonate a service account, so that service account can maybe create those cloud resources that he needs, given he has that permission to impersonate that service account. Yeah, that's it. Thank you for listening. As usual, this entire lesson, step-by-step guide, is in the Academy site. I'll place a link in the description. If you like our content, don't forget to go to our GitHub, star us. You can also star this course. So Academy's Kubernetes Flux. You can also star this course. It currently has 27 stars, and it's I think the only repository, full architecture of managing Kubernetes in the GCP cloud with Flux properly. So star us in here as well. and also comment and like in YouTube. And thank you for watching. See you in the next lesson.